Peak reading voltmeter for impulse voltages. Peak reading voltmeter for impulse voltage measurement. Okay, this is one of the basic circuit. By using the basic circuit, we have to measure peak voltages, peak impulse voltage by using this one of the basic circuit. Okay, so corresponding basic circuit, this is called equivalent circuit of the peak reading voltmeter. Okay, so this is our input voltage V of t. Input voltage V of t, that is called our impulse voltage V of t. Here we have to apply the impulse voltage to the peak reading voltmeter. So V of t is called our impulse voltage. You know well, standard wave shape of impulse voltage. There is a wave front term, wave tail term. We have to measure peak value. Okay, peak reading voltmeters are used to measure impulse voltage wave and routine impulse testing work. Okay, so this so like this impulse. This is called impulse voltage wave front term and wave tail term. Fine. So up to here, this is called wave front term. Okay, this corresponding this term is called 10 to 90% is called wave front term. Okay, and this corresponding 50% of the time, okay, is called wave tail term. Okay, wave front term. This is our actual input voltage. Understood? This is our input voltage V of t. This is our input voltage V of t. This is called our impulse voltage. Okay, this impulse voltage is applied to the meter, peak reading voltmeters. Here we have to apply that impulse voltage to this basic peak reading voltmeter. Okay, in this peak reading voltmeter, so this is called diode. The diode allows only positive pulses. Okay, for negative pulses, the diode will become reverse biased, and it is not allow the signals, impulse signals. Impulse voltage is not allow the impulse voltage for negative pulses. It is allow only positive pulses. Okay, so that's why it's a peak reading voltmeter is suitable for only for this. For the circuit is only for positive pulses. If you want to allow the negative pulses, the diode must be reverse biased. You have to change it. You have to connect in another polarity. Am I right? So this diode is allows only positive pulses. So if you want to allow negative pulses, the diode is connected in a reverse manner, reverse fashion. So then only it is allows negative pulses. That means this peak reading voltmeter, this type of basic circuit is so suitable for only one pulse, impulse pulse, one positive pulse or otherwise negative pulse. Okay, so we have to apply this here impulse voltage, our input voltage. This is our input voltage V of t, and then this voltage can be measured by using this vacuum tube voltmeter or electrometer. Okay, so how measure the for positive pulses? For positive pulses, here positive, for example here negative, that is called positive impulse voltage. Positive impulse voltage. So the diode is forward biased. The diode is forward biased, and the capacitor charges to peak value in this direction. The capacitor charges polarity like this. Capacitor is charging in this polarity. Okay, for peak value of voltage. Peak value of voltage, for example, Vm or Vp. Okay, for peak value of voltage, the capacitor charges to peak value of voltage for positive pulses. Okay, and if the impulse voltage, for example, input voltage decreases the peak value. Okay, below the peak values, for example, here up to peak value, this is called our peak value. Okay, up to here the capacitor charges to maximum value Cm. Capacitor is input voltage up to here, capacitor charges, and then our input voltage decreasing. Okay, like this. For this condition, capacitor is there is a possibility of discharge the capacitor is in direction, but the diode is not allow the reverse direction. Okay, the diode is not allow in this reverse direction like this. Capacitor is not discharging in this direction because of it is reverse bias. Okay, reverse because of reverse bias. So the capacitor is not discharges. Okay, that means the capacitor peak value of voltage is same as previous value. Okay, during input voltage decreasing condition. Okay, input voltage decreasing condition also, this capacitor voltage is called maximum value. That voltage can be measured by using vacuum tube voltmeter or electrometer. Understood? Okay, so the wave shape of impulse voltage might be known. We known already. This this completed explanation. Impulse voltage wave front term and wave tail term. This is our standard impulse voltage waveform. Okay, this is our standard impulse voltage. That is, we have to apply this input of the basic peak reading voltmeter. Okay, and the measuring input instrument is connected to the low voltage side of the potential divider. So potential divider, low voltage side, this peak reading voltmeter is this input voltage we have to connect secondary side of the potential divider, and so corresponding equivalent circuit. This is our equivalent circuit. In this equivalent circuit of basic circuit, so the diode is having some resistance that denoted by here R. This R is called diode resistance, dynamic resistance on the diode. Okay, it is a very ideally this during forward biased, this ideally the resistance is 0, but reverse biased, under reverse biased condition the diode resistance is infinity, ideal condition. But in the practical condition, so the diode is having some forward resistance, and also reverse biased condition is also having very high resistance practically. But in ideally the forward resistance of this diode is 0, and the reverse biased condition, the reverse biased resistance of this diode is infinity ideally. But practically it is having some resistance. So this, because of this resistance, there is some voltage drop. Because of this resistance, some voltage drop takes place. Voltage drop takes place because of this resistance. Okay, because of this resistance, some small amount of voltage drops take place. That is called error. Okay, that is called error. This is denoted by delta. Okay, so VMF of T is less than P of T. Because of this error, so meter voltage is less than our input voltage. That is called V of T because of this error. Okay, because of this resistance of the diode, forward resistance of the diode. Okay, during positive half cycle, diode deconducts and impulse voltage V of T appears across the low voltage arm of the potential divider. This is a low voltage arm of the potential divider, and the capacitor CM charges to the peak value. This capacitor charges to this peak value. Forward resistance of the diode is assumed to be finite. Okay, like this. During negative half cycle, diode reverse bias. Okay, during negative half cycle, diode is reverse bias, and amplitude of the signal start decreasing like this. Amplitude of the signal start decreasing and prevents discharging of the capacitor. Okay, CM. Now measured voltage V is less than the actual value of circuit. Okay, this can be modified by using RC network. To measure peak voltage accurately. Okay, one RC circuit we have to measure this accurately without errors. So this is our actual input voltage V of T, but our meter voltage is called VM of T. This is our VM of T. Okay, our peak voltage is called, this is the peak voltage, but our meter voltage is called, this is the meter voltage. So this is a small amount of error. Okay, this error is nothing but because of diode resistance, forward resistance of the diode, finite resistance. Because of the resistance, there is a small error present in the measurement of peak value. Okay, measurement of peak value, that is called resistance. Okay, this can be overcome by using simple RC network. Okay, by using simple RC network and either polarity. So this type of basic circuit is used for only one polarity. Am I right or not? This type of circuit is only suitable for only positive pulses. This basic circuit is suitable for only positive pulses, only one pulses. Okay, it's not suitable for either polarity. If you want to design the circuit is another pulse, negative pulse. Okay, the diode must be replaced by in another manner, another fashions. So like this, we have to replace the diode like this. Okay, that means we have to design this basic circuit is another way. Okay, that means two basic circuits are required. That means this, by using this circuit, we have to measure only positive impulse voltages. Negative impulse voltages not because of diode. Okay, if you want to measure negative impulse voltage, the diode must be connected in another fashion. Am I right? So this is the drawback, and also there is some error present in the Okay, so measurement of voltage. This is small error. Delta is called small error. Okay, so we have the output voltage is not equal to the input voltage. Our measurement of peak value is not equal to the input voltage. So this is because of this error. Okay, and is not suitable for either polarity and suitable for only one pulse of one polarity. That's why this all drawbacks can be overcome by using RC network. That is called this is the peak reading voltmeter for either polarity with resistance potential divider. Resistance divider. This is called peak reading voltmeter for either polarity. Either polarity. That means it's suitable for positive pulses and negative pulses. And also there is no error present measurement of voltage. Okay. So here this is called high value of resistance R1, high value of resistance R1, and this is called low value of resistance R2 of resistance divider. This is called resistance divider. High value of voltage appear across the R1, or remaining small value of voltage appear across the R2, and then this R2 across the R2 we have to connect this our peak reading voltmeter. So like this fashion. This is a color resistor is called discharging and charging resistors. Okay. So like this we have by using this connection RC network connection we have to measure the peak value of input voltage in either polarity or positive pulses or negative pulses, whatever may be polarity of the input supply, that can be measured by using this peak reading voltmeter for either polarity with resistance differential. So it is called surge impedance of the cable. Okay, the cable used to avoid the reflections. Any reflections are there in the input side that can be overcome by using the surge impedance cables. And this is called a peak reading voltmeter for either polarity with the capacitance divider. This is called capacitance potential divider. So this capacitor C1 and capacitor C2, for capacitor C1 input side, high voltage terminal is connected like this. Input of the capacitor C1, that means the capacitor C1 is made by compressed air or gas type. Compressed air or gas type capacitor, this C1. And C2 is called a standard capacitor, that is called mica or paper. So this is called low value of capacitor, and this is called high value of capacitors connected like this. So this high voltage offered by this C1 only. So remaining voltage, small voltage appear across the capacitor C2 that can be measured by using our basic meter, basic peak reading voltage. So this is about peak reading voltmeter to measurement of high voltage, high peak impulse voltages for measurement of high impulse voltage. So the basic, this is called basic impulse circuit, is having some drawback. It is only suitable for only one polarity. It is not suitable for either polarity, and also it's having some forward resistance drop. Okay, voltage drop. That is because of this some small amount of error present for measurement of peak value. This can be overcome by using simple RC network, that is called peak reading voltmeter with either polarity resistance divider and peak reading voltmeter with either polarity capacitance divider. Okay, so this is having some advantages. Fast rising pulses or impulse voltage wave can be measured. This is one of the advantages of the peak reading voltmeter. Fast rising pulses or impulse waves can be measured. And also capacitor is used to prevent the buildup of DC volt charge. This is one of the, so these are the two different types of advantages of this peak reading voltmeter.